Assalamualaikum everyone. Now we are studying parallel programming and hardware implementation of full adder and subtractor 4 cross 1 mux and 1 cross 4 De-mux using Quartus software and FPGA hardware. Our objective parallel programming and hardware implementation address and subtractor parallel programming and the hardware multiplexer and demultiplexer. Equipment software used and this is Quartus 1310 Cyclone V and power cable USB cable blaster and adder. Adder used to add multiple binary input and give their carry and somewhat different output. And there are two types of adder. Half adder which will act works on the two inputs and full adder which has three inputs. And this is adder. Adder becomes sum and carry. This is full adder. We have two XOR and one OR and two AND. Three input C is in and A and B are inputs. Subtractor uses subtract binary weights and give the carry result on a two different output. There are two types of subtractor. Half subtractor which works on two inputs and full subtractor which on three inputs. Full subtractor takes two binary input and plus a carry or flow bit or difference and another carry bit. Full subtractor are made from XOR and not gate hardware. Full subtractor are commonly connected to each other and to subtract bits of the arbitrary length. A full subtractor is effectively two half subtractor and a XOR which gives the difference and gets connected by NOT gate which are generated by OR gate which will carry bit C. Half subtractor is this and mux is a device that has multiple inputs and single line output. The select line determines whether input connected to output and increase the amount of data which can be sent over a network within a certain time. It is also called data selection. So we have sent over a network within a certain time, which is also called a data selector. And multiple handling both analog and digital applications and analog application multiplexer is made up of delays and transistor switches, whereas in digital application the mux are built for standard logic gate. Demultiplexer. Demultiplexer is also a device with one input and multiple output lines. It is also used to send a signal to one of the many devices. The main difference between a multiplexer and demultiplexer is that multiplexer takes two or more signals and encodes them on wire, whereas the demultiplexer reverse to what the multiplexer does. This is a lab task. Full adder subtractor, mux and demux. Full adder would produce when both 0, C in 0, then sum is 0. When both are 0, C in 1, then sum 0 and carry 1. When A0, B1 and C in 0, then sum 0 and carry will be 1. And similarly, when A is 1 and B is 0 and C in 0, then the sum is 0 and carries 1. When both and A is 1 and B is 0 and C in 1, then sum 1 and carry 0. And when both are 1 and C in 0, then sum is 1 and carry is off. So as well as when three when all of three are 1 and then sum and carry will be 1. And here is the so it is adder, full adder, which is adding two inputs and C in 1 is the input and C is input. What will be sum or carry aside the sum is equal to A B plus C. This is the block diagram and this is waveform. This is RTL viewer and this is waveform. And this subtract full subtractor. In this we have three inputs on both and one subtract. Then we have wire selected and XOR is equal to sum is equal to subtract A, B and C. Then when not and three and using Y then B, C and we're going to see. This is our RTL viewer and this is waveform. So we are moving on to our task number 3, which is marks and with 4 inputs and 1 output and 2 selection lines. This 4 input and 2 selection lines and one is output is E. And this is the code for marks. And this is code waveform wave generated, and this is RTL beaver. Task 4 is the De-mux. We have B is the output and A is the input and D is the data. This is RTL user waveform. So hardware task 1, and this is task 2 for this is full adder, this is full subtractor, and this is mux, and this is demux. So in this lab, we have learned about the value of HDL and have analyzed different works for the value and its condition. We have learned the effect of RTL and waveform on this analysis. Analyze the working condition thoroughly. We have also percent practical implementation of FPGA. So this is the end of the series of microcontroller embedded systems, which are using different concepts. Uh, STA, FPGA, Verilog, SDL, and similarly interrupts, video, UBM, and LCD configuration and introduction implementation of assembly language and C language, plus in order to restart and different concept. Hope you like the video and subscribe for more videos. And if you have any queries, do ask in the comment section. Hafiz.